and welcome viewers. In today's lecture, we are going to study the basic concepts of PLA. A PLD or programmable logic device has an array of logic gates and interconnecting with array inputs and outputs connected to the device pins through fixed logic elements such as inverting and non-inverting buffers and flip-flops. PLDs are of two types: Programmable Logic Array or PLA and Programmable Array Logic PAL. PLA. The internal architecture of PLA device is given. The PLA consists of and OR gates in a single chip. The number of gates and their inputs are fixed in a PLA chip. The AND gates are used for the product terms, whereas the OR gates are used to sum these product terms, thus generating a SOP form of expressions. It has M inputs, N product terms, and N outputs, thus implementing the logic function of M variables with N outputs. As we all know, the possible 2 to the power M minterms are not available. Hence, logical minimization is required to accommodate a given logic function. Input buffer. The input buffer circuits are required to limit the loading of sources driving the inputs. It produces inverted as well as non-inverted inputs at the output for one input. Similarly, buffers are there for each of the M inputs. An AND matrix is shown here. An AND matrix is used to perform the product terms. It has N AND gates with outputs P0 to Pn-1 and 2 M inputs, that is I0 to Im-1 and I bar 0 to I bar M-1 for each AND gate. This shows that the AND gates have input variables in complemented as well as non-complemented form. There is a nichrome fuse link in series with each diode. The links are intact for a non-programmable PLA device. Each AND gate generates one product term which is given by it is in logic 0 in a non-programmed device. For generating the required product terms, the unwanted links are opened by the method of programming by the programmer in case of a field programmable logic array FPLA. A section of AND matrix is shown with its equivalent logic representation. The below diagram shows the convenient method of showing input buffers with AND matrix and the interconnection is marked as XS. OR matrix. The OR matrix is used to generate the SOP of the outputs of the AND matrix. The figure shows the OR matrix using RTL circuitry. The outputs are obtained as S0 to Sn-1. The outputs S0 when all fuse links are intact is given by the unwanted fuse links are opened, thus generating the required sum terms. For example, if all the fuse links are opened, which except the ones for the product terms P0 and P1, then the output is given as S0 is equal to P0 plus P1. Fuse links makes logic level 0 at the corresponding OR gates. This figure gives the logic symbol for OR gates. This figure illustrates the relevant portion of PLA containing OR matrix. Invert and non-invert matrix. This is a programmable buffer is set for inverting as well as non-inverting operation corresponding to active high as well as active low outputs respectively. In case of an XOR gate, if the fuse is intact, the output is S, whereas the output is S bar if the fuse is blown off. Output buffer. Output buffers are used for improving the driving capability of the PLA. The outputs are TTL compatible. The outputs can be totem pole, open collector, or tri-state. Output through flip-flop and buffer. The PLA devices have flip-flops and buffers in the output circuitry. In this positive edge triggered SR flip-flops are connected at the outputs of the OR gates. The device outputs are available through tri-state buffers. Programming of PLA. A PLA device is to be programmed for the desired input-output relationship. For the mask programmable PLA device, the data pattern is specified by the customer and the appropriate masks are designed by the manufacturers. Expanding PLA capacity. To increase the number of product terms, the number of inputs and outputs are unchanged. The inputs and outputs of two or more devices are connected individually in parallel. This is shown in the circuit which has M plus Q inputs and N outputs. This connection also increases the number of product terms, where the number of product terms is P into 2 to the power Q minus 1. Applications of PLAs. The PLAs are used to implement combinational and sequential logic circuits. The following steps are used for implementing combinational logic functions. Preparation of the truth table. Writing the Boolean expression in SOP form. Minimization of Boolean expression. Input connections of AND matrix is generated for the required product terms. Input connections of OR matrix is generated for the required sum terms. Input connections are required for invert, non-invert matrix to set the active logic levels of the output. Programming the PLA. Available PLAs. Some of the available PLAs are given in the table. In today's lecture, we have learnt types of PLDs, introduction to PLA, input buffer of PLA, AND matrix of PLA, OR matrix of PLA, invert and non-invert matrix of PLA, output buffer of PLA, output through flip-flop and buffer of PLA, programming of PLA, expanding PLA capacity of PLA. With this, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.